All right, in these problems, what we're going to do is we're going to use L'Hopital's rule to find the limit. And L'Hopital's rule doesn't work in all situations, but it especially works when you have a fractional expression, and that's what we have here, and where you can find the limit of both the numerator and the denominator. So let me go ahead and try to do that here. So you have the limit as x approaches 0 of 1 over 1 plus 0 squared minus 1, and we see that 0. And then also we find the limit as x approaches 0 of x, and that's 0. So what I'm getting at is this is a 0 over 0 form. And 0 divided by 0 is undefined. So, we can't just find the limit of the numerator and the limit of the denominator separately and then just divide the two. So we have a 0 over 0 form, and it's an indeterminate form. What we can do then is apply L'Hopital's rule, which says that if we have a case like this where the limit of the numerator is 0, the limit of the denominator is 0, then what we can do is we can take the derivative of each of those. And so the derivative of 1 plus x to the minus 2 is minus 2, 1 plus x to the minus 3. And then the derivative of negative 1 is 0. And in the denominator, the derivative of x is 1. So this is without really changing anything, but just rewriting it. This here is when I now find the limit by plugging in x equals 0, which I can do because this is a continuous function, I get negative 2. And that's the limit for that one. All right. Now let's go over to the next problem, which is going to have a similar situation where this time when I find the limit in the numerator, I'll just draw an arrow here. So this numerator has limit cosine pi over 2, because cosine is a continuous function. I can just put in pi over 2 to find the limit. Pi over 2 is 0. And in the denominator, I have pi over 2 minus pi over 2 when I put in x equals pi over 2, and that gives 0. So this is a 0 over 0 indeterminate form. Usually I just write form or just put 0 over 0, but because indeterminate is such a long word. Well, anyway, let's go ahead and take L'Hopital's rule here, where again I take the derivative of the numerator and the denominator. The derivative of cosine x is negative sine x. And the derivative of the denominator, well, what's that? Derivative of pi over 2 is 0. Okay, the derivative of negative x is negative 1. So now I can go ahead, the negative in the numerator and denominator cancel. And so I have just sine of pi over 2, and sine of pi over 2 is 1. So that's the limit. Let me move that down to create a little more room there. Okay, so I write that little notation LH to indicate that I'm using L'Hopital's rule, taking the derivative of the numerator, take the derivative of the denominator, and I get a new limit, which is the limit of sine x. Sine x is a continuous function, so I can just put in x as pi over 2, and I get that as my limit. Next, let's go on to this next one. Well, this next one is not a fraction, so we really can't use L'Hopital's rule right away. We have to play around with it, manipulate some of the things, or just move things around. So x squared as x goes to infinity is infinity. E to the x is x goes to infinity is 0. Let's just do a real quick reminder of what's going on with e to the negative x. Roughly speaking, this is the graph of e to the negative x. So you can see that the limit's 0. But this isn't a fraction, so what we do is, this would be considered a indeterminate power. That's a form, an indeterminate power, but it's an indeterminate form. Oh gosh, do I have to write down indeterminate each time? Maybe I just copy and paste this. It's an indeterminate form. Okay, so what I can do though is what I should do each time is I should turn this into a fraction, now e to the negative x sort of naturally can be written as I'm showing here, 1 over e to the x. And in this situation, x is going to infinity, so I have infinity, the limit of x squared is infinity, and e to the x, the limit's infinity. So now that's an infinity over infinity form, which is one of the indeterminate forms that I directly use for L'Hopital's rule, where I use L'Hopital's rule directly. And again, I take the derivative of the numerator, that's going to be 2x, and the denominator, the derivative of e to the x is e to the x. Still, infinity over infinity form. So once again, I use L'Hopital's rule. I make a little indication that I'm doing that just to give whoever's reading this a heads up. And I'll have 2 over e to the x. Derivative of 2x is 2. The derivative of e to the x is infinity. Now it seems like we're all done, but I don't know. Sometimes I feel like students have a little trouble on this. Think about what's going on. The denominator is getting very large. And so you have 2 divided by a large number, so the limit is 0. I mean, you could also express this as 2 times e to the negative x, and we have the graph of e to the negative x. Okay, you can look at it that way. Just this is, even though I wrote 2 divided by e to the x, it could be 2 times e to the negative x, and the graph of e to the negative x is above. And on that graph we see as x goes to infinity, y approaches 0. There's a horizontal asymptote y equals 0. All right, now let's go on to this next one. For this next problem, we're going to have to use a little bit of a limit formula, a derivative formula that you might be a little bit rusty on, but let's just do that in a moment. If I plug in by continuity, I can substitute x equals 0, and I get 1 minus 1 is 0. So the numerator is going to 0, same with the denominator 0. And then we have a formula that says the derivative of a to the x is a to the x ln a. Okay, so we'll use that formula here. And so for using L'Hopital's rule then, the derivative of the numerator, all right, so on the side then, if a to the x has derivative ax ln a, then 3 to the x has derivative 3 to the x ln 3, and the derivative of 2 to the x is 2 to the x ln 2. So let me just go ahead and write that over here. And then that's the derivative of the numerator. The derivative of the denominator is just 1. That's easy enough. So now by continuity of 3 to the x and 2 to the x, I just plug in 0, and that gives the answer. I mean, I know I went through this a little bit quickly, and part of that is that I could spend more time on, for example, explaining that sine of pi over 2 is 1, or I could talk more about this formula that I wrote down. But then again, you know, long videos are sometimes not as popular. Okay, what the heck happened here? So I'll just end on that note. Okay, let me zoom out first. These problems are from Openstax Calculus Volume 1. It's open source textbook that you can find at openstax.org. I'm a teacher. I don't have any affiliation with that organization, but we're using this textbook in the spring. Okay, then thank you. Bye.